Last Thanksgiving, I had to wake up at 3 a.m. and drive my girlfriend to Houston so she could catch a flight home for Thanksgiving. It was frustrating, but hey, flying is expensive, especially flying out of a small airport like College Station. Electric planes, which use simple motors and batteries and don't need expensive fuel, could fly these routes cheaper and more often. But we aerospace engineers can't design any electric planes because, well, gas engines are built into our equations. For example, the equation to predict a plane's range assumes the plane is getting lighter as it burns gas. Last I checked, your phones didn't burn away their batteries and get lighter. I'm researching 3 new kinds of equations that help aerospace engineers design these future electric planes. Equation number 1, size. Just how big of a motor or battery do you need for a particular plane? We don't want the motor so small that the plane doesn't have enough power to take off. We also don't want the motor so big that the plane is too heavy to take off. We want something in the middle that's just right. Equation number 2, range. Just how far can you fly with an electric motor and battery? We want the plane to reach its destination and have extra power left in case there's bad weather or some sort of emergency. Equation number 3, temperature. How will these new parts behave when they get hot? We've all seen how our phones can get hot and slow down after a long phone call. We want the plane's motors and batteries to keep working well after they get hot. So speaking of heat, coming up with these equations has been a lot like cooking. I started by looking at electrical engineering textbooks for equations, the same way you might browse the internet for recipes. Once I found an equation I liked, I threw out ingredients that I didn't really care for, and I added ingredients that I, as an aerospace engineer, really can't live without, like weight and range. Then I compared my equations to the good stuff, measurements from real motors and batteries in our lab. So far, my equations do pretty well. They predict real data accurately, and engineers from Boeing, NASA, and the Army are starting to use my equations to design electric aircraft. So what have I learned? Well, for starters, don't make your battery voltage too high. High voltage is efficient on the ground, but in the air, low voltage is safer. When you're picking your motor, go for a wide and short motor rather than a long and skinny motor. Think hamburger over hot dog. The more efficient motor will be able to squeeze more range out of a battery, and that lets the airplane reach more regional destinations like College Station or Tyler. Finally, one medium motor and a small helper motor is actually lighter than one big motor. The extra motor will come in handy in an emergency, and the lighter weight will save airline costs and pass on those savings to your ticket. So who knows? Maybe your first cheap flight out of College Station will be on an electric plane designed with my equations. Thank you.